Hi guys, welcome to Science in 5. If this is your first time here, you might want to subscribe. We have lots of exciting maths and science videos that are useful for learning, satisfying your curiosity, and just keeping informed about the world of science. In this video, we'll focus on vectors in 2 dimensions part 2. The skill to be learned is about adding perpendicular vectors. Let's go. In part 1 of adding vectors in 2 dimensions, we spoke about drawing in the resultant vector using the tail to head method or the parallelogram method. Now before you continue, just do a self-check quickly. Number 1. Can I add vectors in 1 dimension? Number 2. Can I draw in the resultant vector? Number 3. Can I use the theorem of Pythagoras? Number 4. Can I use trig ratios? You see, before you continue to add another skill in physics or maths, it is always useful to make sure you've got the background knowledge correct. In this case, these 4 skills are very important to be able to unlock vectors in 2 dimensions. So if you have any one of these skills missing, or it's a knowledge gap that you need to cover up, be sure to check out one of our videos. And once you've done with that video and you're ready to roll, come, let's discuss vectors in 2 dimensions. You'll find that your journey with vectors in 2D becomes much easier. Okay, let's go. So, in the diagram below, we are asked to calculate the resultant force. We can clearly see that these vectors are perpendicular to each other. Okay, so what does this mean? Well, we can already tell that the resultant force, F net, is not going to be equal to 100 plus 80. Why? Because these vectors are not going in the same direction. If the force vectors had been going in the same direction, we would have added them. Okay? We can already tell that the net force is not going to be equal to 100 minus 80 or 80 minus 100. Why? Because these vectors are not going in opposite directions. So, because these vectors are not going in opposite directions, we already know that the net force cannot be found by doing that. But what we can actually tell is that the net force is going to be between the sum of 100 plus 80. So the sum of 100 plus 80 will be what? 180 newtons. The difference between 100 and 80 will be what? 20 newtons. Now I put degrees there. So we know that the net force must be between this range of 20 to 180 newtons. Okay. These 2 forces are not adding up because they're not acting in the same line in the same direction. Neither are they subtracting each other because they're not acting in the same line opposing each other. So what is the method we can use to solve this problem? Well, we can use the theorem of Pythagoras and the trig ratio, or we can just call it the top and trig method. Okay. But before we use the top and trig method, we just need to draw in the resultant force so that we know what the resultant force is going to be. So, how do you do that? A parallelogram method. Draw in a parallelogram by just drawing in parallel sides. So this side here must also be the 80 going down, and I need to draw another parallel side to that blue line, and this side going there will also be the 100. So just to avoid confusing, I need to remove this 80 that was there. Let's place the 80 newtons there so that we don't confuse these two. Okay, so Now that is sorted, so this side is another side 100 newtons. So the resultant now is going to be from where the two tails start to where the two heads meet, like that. That is my resultant force, F net. Okay. So F net is now the diagonal of this parallelogram. But in this case, it's actually, if you look carefully, it will be the hypotenuse of a right angle triangle. Now, since F net is the hypotenuse of a right angle triangle, we can easily calculate it by using the theorem of Pythagoras. F net is going to be equal to the square root of the perpendicular sides, because it is the hypotenuse. Guys, we've talked about the theorem of Pythagoras in one of our videos. You might want to check that out as well. So, square root of 100 squared plus 80 squared will give you 128,062, which you can round off to 128,006 newtons to 2 decimal places. So that is the top part, the theorem of Pythagoras. Then the next part is to use the trigonometric ratio to get the angle. I normally say go for the angle theta that is measured from the horizontal to the vector. In that case, you can now just simply say the tan of theta is going to be the y vector over the x vector. In this case, the y vector is the 80 and the x vector is the 100. So we now know that theta is equal to the arc or the inverse of tan 80 over 100. Okay, and that becomes 38.66 degrees to 2 decimal places. Now that we've got the angle theta 38.66, the last thing to do is just to give the direction. You can clearly see that this vector F net is in between the east and the south. Okay, so it's between the east and the south. So you can start by just simply saying the direction now will be 38.66 degrees from the east. Where you're going, if you move like that, you're going towards the south. Okay, so it's going to be south of east. Alternatively, you can also say I can measure this angle here by using this idea of complementary angles. If theta is 38.66, what do you think this angle will be? Let's call this angle beta. What will be the size of angle beta? It's going to be 90 minus 38.66. Okay, which will give you 51.34. So, or you can also say 51.34 degrees east of south. Okay, so that is how you can calculate the resultant of two perpendicular vectors. Use the theorem of Pythagoras and then use a trig ratio to get the direction. Right. Before we move on to the next example, maybe we just also need to highlight that you can also write the direction using a third method, the bearing method, where you're going to say the north is the same as 0 degrees. So if the north is taken to be 0 degrees, we're going to measure the angle going in a clockwise direction. Okay, so let's measure this angle going in a clockwise direction. So from north to east, we know that's a right angle. That's 90 degrees. So the angle measured from the north will be 90 plus theta. So you could also say, well, the direction could be 90 degrees plus the 38,66, which comes out to a bearing of 128,66 degrees. Again, guys, it's not a rule that you always say 90 plus the angle, because I know some learners say, oh, so every time I want to work out using the bearing method, I'm going to say 90 plus the angle. No. Look from your diagram, where is the north and where is the vector actually going. From then on, you can simply see what angle you need to add to get the bearing of that. Okay, so don't disappear now. Let's look at another set of examples where we explore this top and trig technique. It's a technique that you need to always add perpendicular vectors. So once the vectors are perpendicular, in other words, the angle between them is 90 degrees, you will use the top and trig method. So in this diagram, we are asked to calculate the resultant force that is acting in the diagram below. Now, when we look at this, we can see that there are horizontal forces and there are vertical forces. Okay, so what if we calculated the sum of the forces along the horizontal or along the x direction, and then the sum of the forces along the y direction? That would give us perpendicular vectors. And once we got perpendicular vectors or forces, rather, we can then easily use the idea of the top and trig, or this technique of the top and trig. Sounds like a plan. Okay, let's try that. So the first thing I'll do is, let's draw a free body diagram. In other words, let's just replace the box with a dot, and then let's draw all the forces that are acting as pulling forces. So in other words, the 140 newtons is a pushing force on the box, but in this diagram I'm going to draw it as a pulling force. So there's my 140 newton, and then the 60 newton is now going in that direction. There's my 60 newton. The 30 newton is now going downwards, 30 newtons, and then the 70 newtons is now going upwards. Now, once I do this, I've got vectors that are acting in 2 dimensions, but the 2 dimensions are the y dimension and the x dimension. What if I make one of the directions positive? If this was a Cartesian plane, the east direction will be the positive direction, and then the west will be the negative direction. On the y-axis, going up would be the positive direction. Okay, so now this allows me to actually calculate the sum of the forces along the x. Okay, so along x axis, the sum is going to be what? 60 minus 140 to give me negative 80. The 60 is a positive force because it's going in the east. The 140 is a negative force. It's going in the west. Then I'll do the same for the y. Along the y, I'm going to have 70. It's going in the positive. Minus 30 to give me 40 newtons. Okay, so now I've got the sum of the forces that are acting in those 2 directions respectively, or 2 dimensions. So now I can easily draw in a sketch of the resultant. So the sketch of the resultant will now look like this. On the x, I go back 80. Then on the y, I'm going positive 40. Now, the resultant vector must be the diagonal of the parallelogram that I draw in by manipulation. So if I draw in a parallel side to the 40, and I draw in another parallel side to the 80, the diagonal from the two tails to the heads, there is my resultant force, my F net, and there is my angle theta. Guys, remember always the angle theta is easier if you draw it from the horizontal axis to the vector. And then I now know that these forces are perpendicular because why? The x-axis and the y-axis are perpendicular to each other. So these are perpendicular vectors. So I can now easily calculate the magnitude of the resultant by simply saying F net is now equal to the square root of negative 80 squared plus 40 squared. This gives me what? The square root of negative 80 squared plus 40 squared is 89,4427. We can round that off to 89,44 to 2 decimal places. So it's actually 89,44 newtons. So the magnitude of the resultant of this system of forces is 89,44. Okay. What we now need to get is the direction. Now, we have done the top part. Top part simply means use the theorem of Pythagoras. We're calling this technique top and trig technique. So we are basically using the theorem of Pythagoras. Now we're doing the trig part, which means let's use trig ratios to get the angle theta. And I said it's easier if we use the tan of theta, which is always the y vector over the x vector. In this case, the y vector is 40 and the x vector is 80. Notice I've used 80. It's always easier not to use the negatives when you're calculating the angle. Okay. So theta becomes the inverse tan or the arctan of 80 over 40. Okay. And that becomes 26,565, which can round off to 26,57 degrees. So if that angle there is 26,57, and that is the northern direction or the positive y, and that is the west. So this vector is between the north and the west. So if you measure that angle theta starting from the west, you're going towards the northern direction. So the direction now, because we've already got the magnitude, we're going to say it's 26,57 degrees north of west. Okay, north of west. Can you give the other direction? Can you give the other direction? Can you calculate that complementary angle to theta? Maybe you can call it beta. So the angle beta will be from the horizontal to the vector. Okay, you could calculate that angle. You'd get what? Or you could say the direction is actually 63,43 degrees west of north. Okay, 63,43 degrees west of north. Or you could also use a bearing method. To use the bearing method, remember we always say start from the north, which you make 0 degrees. Okay. So what's happening in this diagram, you're having your resultant vector going like that, and we've calculated this angle theta. Okay, so from the north to the east to the south and then to the west, what is the size of that rotation? That's 90, that's another 90, that's another 90. That's basically 270 degrees. So it's going to be 270 degrees plus the 26,57, because we've already said theta is 26,57. Okay, so you could also say, well, or bearing of 270 plus the 26,57 becomes 296,57 degrees. Again, you could also calculate this angle by looking at this angle. Okay, if you know what this angle is, 360 minus this angle will give you the 296,57. But this angle we've just said is the 63,43 degrees, because these two angles must give us 90. So 360 minus 63,43 will still give us the same answer of that, the bearing of 296,57. So when you have a system of forces acting along the x, along the y, add them up, get the sum of the forces on the x, get the sum of forces on the y, use the top and trig method, and you'll be able to solve that problem. In this diagram, we're given another system of forces that are acting, and we are told if the resultant force is 70,71 newtons, 45 degrees east of north, determine the magnitude of force F4. So here is force F4. I can clearly see that these forces are acting perpendicular to each other. Okay, so again, is this idea of perpendicular vectors being tested here, because there is the horizontal axis and there is the vertical axis. What is clear in this diagram already, I can see that I can easily determine the sum of the forces along the vertical, and I've been told the magnitude of the resultant. Let's draw a sketch. Okay, so let's draw a sketch. So let's say now so the resultant force we are told the resultant force is 70,71 newtons, 45 degrees east of north. So if I make a sketch there and I say that is my north, make that the north, make that the east. So this force is actually going like that, right? And then they say it's 45 degrees, so this is 45, so which means this angle again is going to be 45. Okay, now so that is the resultant force, but we know that the resultant force is always the diagonal or the hypotenuse to a right angled triangle, so which means we can draw in the two sides of this right angled triangle, and the two sides of this right angled triangle are the sum along the x and the sum along the y, and there's my F net there. Okay, so I already know that the F net is 70,71, so let me write there 70,71. Alright, I think this puzzle is looking much easier to solve because I've got 70,71 and then I've got an angle of 45 degrees here. Okay, so which means I can easily work out Fy and Fx by using the trig ratios. Remember the trigonometric formulas, there are 3 variable formulas. Once you get 2 pieces of information, you can always work out the third. But let's work out the resultant along the y. Okay, so the resultant along the y, Fy sum, is going to be equal to 60 minus 10. Why 60 minus 10? Because going up on the y is the positive direction, going down on the y is the negative direction. So this gives me a total of 50. So Fy is actually 50 newtons. Okay. So this side of this right angled triangle is now 50 newtons. So now I got two sides of right angled triangle with an angle there 45 degrees. To work out Fx is now easy. Okay, I can now easily work out Fx. How am I going to work out that side of that right angled triangle? I could use the theorem of Pythagoras. It's a right angled triangle. I could use the theorem of Pythagoras, which says the hypotenuse squared, the 70,71 squared, should be equal to 50 squared plus Fx squared. Okay, so this can simplify to 70,71 squared minus 50 squared is now equal to Fx squared. Notice I'm still using the theorem of Pythagoras. Take square root of both sides. You're going to have Fx is now equal to the square root of 70,71 squared minus 50 squared. This comes out to 49,999, which we can just say Fx is 50. Which actually makes sense if you think about it. If this side is 50 and this angle is 45, if one of the angles in a right angled triangle is 45 degrees, it simply means that is an isosceles right angled triangle. If this angle here is 45, that angle there must also be 45. So, which means the sides opposite those equal angles must be equal. So Fx must also be 50. Okay, so using the theorem of Pythagoras, you can prove that Fx equals 50. Another way you could do this is by simply using either one of the trig ratios again. You could use the trig ratios. Now to use the trig ratios, we have to assign these 3 sides of the right angle triangle special names. Okay, so we normally focus on the angle that is from the vector, from the horizontal to the vector. So which means the 50 or the y becomes the opposite side. The 70,71 is the hypotenuse and the Fx is the adjacent. So you could use opposite and adjacent, that's 10, to work out Fx, or you could use adjacent and hypotenuse, which is cos, to work out Fx. So I could say that 10 of 45 is equal to opposite over adjacent, in this case, which is the 50 over fx. Right? So what I need here to do is to make the tan 45 go over 1 is now equal to 50 over fx. From there on, cross multiply, you get fx times tan 45 is equal to 50 times 1, which is 50. Divide both sides by tan 45, so now you get fx equals 50 divided by the tan of 45. If you use that on the calculator, you discover that the tan 45 is 1. You still get your answer of 50. So again, using trig ratios, we are getting that the sum of the forces along the x is also 50. The other trig ratio you could use is the cosine in this particular example. Okay, so you could have said the cos of 45 degrees is the adjacent over the hypotenuse. The adjacent is the fx. The hypotenuse is the 70,71. Again, if you do the thing of cross multiplying, you get 70,71 times the cos of 45 is equal to fx. Fx is now equal to, this simplifies to 49,999. Round that off to 2 decimal places. The sum of the forces along the x is also 50. Okay, so now we know that this side here is actually 50 newtons. So how does this help us to get what F4 is? Well, we know that the sum of the forces along the x is found by adding the forces along the x. In other words, the 50 newtons, which is the sum along the x, is equal to a negative 100 plus force F4. Again, why is the 100 newtons being made a negative? Because it's going in the negative direction. The positive direction is to the right. Okay. And then, from then on, it's an issue of adding 100 to both sides to get rid of the negative 100. You get 150 newtons is equal to F4. So guys, that's how you can look at vectors in 2 dimensions. When you're looking at vectors in 2 dimensions, acting along the x and y plane, or the horizontal or vertical plane, use the top and trig method. Okay, use the top and trig method. The top and trig method simply means, first step, use the theorem of Pythagoras. Second step, use the trig ratios to get the angle measured from the horizontal to the vector, and then now determine the direction. Once you've got the angle, you now know how to get the direction. So that's it guys, how you can add perpendicular vectors. Okay, so in the next video we now need to look at what happens if the vectors are not perpendicular to each other. What happens if the vectors are not perpendicular to each other? Thanks for watching guys. Hope you enjoyed the video. Don't forget to share, subscribe, like, add a comment. See you guys around next time.